In this module, we're going to look at how to diagnose the low-speed bus. Low-speed bus faults are not difficult to diagnose once you know what type of fault you're looking for. We'll look at the types of faults that can occur and how to isolate their location. Armed with this knowledge, you'll be able to confidently tackle any low-speed bus fault that comes your way. This is a low-speed bus schematic for the vehicle I'll be working on. Always remember to check the schematic for your vehicle. It uses star topology with a removable splice, which makes diagnosis easier. If your vehicle doesn't have a removable splice, it will require a little bit more work to locate the fault. There are two types of faults that occur in a low-speed bus. The first is where there is no communication with any of the modules, and the second is when there is no communication with just one module. A short to ground or a short to voltage will cause the same symptom. You'll not be able to communicate with any of the modules on the low-speed bus. If we have a look at a typical low-speed bus pattern, you'll see that the signal is either 5 volts or 0 volts. If there is a short to ground on the bus, the signal will look like this. If there is a short to voltage, the signal will go to the value of the shorted voltage. Either way, there can't be any data transmitted on the bus. I have the oscilloscope hooked up to the low-speed bus. This is our signal. We go from 0 to 5 volts. That's what this vehicle requires for communication on the low-speed bus. If these voltages differ, no communication can occur. I'll put a short to ground in and we'll see what happens. And as you can see, the voltage dropped straight away to 0. No communication can occur on this bus. So all of the modules stop communicating with each other. I'll remove the short to ground, and as you see, our pattern comes straight back. We don't necessarily need an oscilloscope to do the diagnosis on a low-speed bus. We can use a multimeter. We'll turn the multimeter onto voltage. You can see we've got a fluctuating voltage. That indicates there's communication on the line. The voltage will normally be a little bit below the maximum voltage on the bus. We also have a bar graph on this multimeter, and we can see that it's fluctuating up and down as well. That's another good indication that there's communication on the bus. Let's have a look at how we diagnose a short to ground with the multimeter. For this diagnosis, the customer has been complaining that there are a few things on the vehicle not working. For example, rear park assist and the instrument cluster. We've had a look with a scan tool and we see that there's no communication with any of the low-speed bus modules. So we'll probe the low-speed bus between pin 1 and pin 4, looking for communication. And as you can see on the meter, we have nothing. There's 0 volts, no communication occurring. So we must either have a short to voltage or a short to ground. I'll check to find out which one we have. I've now gone between pin 1 and pin 16, pin 16 being B+. I've got 12 volts, so that indicates there must be a ground on pin 1, and that's our low-speed bus wire. So I'm looking for a low-speed bus fault. The next thing I need to do is remove the star connector. As you can see, the voltage has disappeared. That means there's no fault between the DLC and the star connector. We now need to go to the star connector to find out which wire does have the short to ground. And we found the 12 volts showing up again on pin 5. And if we look at our schematic, that goes to the immobiliser. Next thing to do is remove it. With the immobiliser removed, we can see that the voltage is now gone. That means the short to ground must be in the immobiliser, so we'd replace it. If the voltage didn't disappear after removing the immobiliser, it must be in the wiring between the immobiliser and the star connector. If your vehicle doesn't have a removable star point, it will be necessary to disconnect each of the modules in turn to find the short to ground or short to voltage. If all the modules are disconnected and the fault still exists, there is a fault in the wiring. On a double ring layout, the first module to disconnect is the one that shares both rings. In this case, it would be the body control module. If the fault disappears when the BCM is removed, the problem will be in the left ring or the BCM. If the fault still exists, then it will be in the right ring. Now it's a process of eliminating each module to find the fault. If the fault still exists, it must be in the wiring. This time the customer is complaining that they can't get into their vehicle using their remote. We've had a look with a scan tool and can't communicate with a keyless entry module. Modules require 3 things to communicate. 1 is comms, 2 is battery, and 3 is ground. And that's what we're going to check for. So we'll disconnect the module. I'm checking for a ground. So I go between the ground on the module and pin 16 on the DLC, and I got 12 volts. That means I have a good ground. This time I'm hooked up to the bus wire on the module connector and pin 4 of the DLC. And as you can see, I have a fluctuating voltage. My bar graph is also moving. This is a good indication that I have comms on the line. So I have battery, I have a ground, and I have comms. The only fault that we can have is the module. If one of those was missing, that would have been our fault. So that's how to diagnose low-speed bus faults. As you've seen, it's not difficult, but it does require a systematic approach. Follow the method. Determine what type of fault you have, and then use the step-by-step procedure to locate it. Doing this will allow you to confidently approach any low-speed bus problem. And always remember, training is the key to your success. Bye for now.